last period. Okay, so that different periods will do different problems, so if you want to watch along, then, we're not watching whatever, it's up to you. All right, so I'm on review 1, that's the one that doesn't say 2 on it. What questions do we have, Thomas? 14. Now, 14 is another one that you are not responsible for all of it. So on your test, there won't be all this other stuff. You will have only an equation that looks like this. Now, none of this other stuff matters when we're talking about amplitude and period, and that's all you need to know about. We didn't cover the rest of it. We didn't talk about the rest. So amplitude and period. Okay? Yeah, they're all back there. There's a million back there. Amplitude. Who remembers anything about amplitude? Well, it's the height of the curve, right? So it would be 4. Now, that's a little tricky. Amplitude is always positive. So the negative, remember, turns the picture upside down if we were graphing, but we're not graphing. We're just saying how tall are the hills and valleys. Therefore, that's the amplitude. Period. The period of a sine is 360. But you have to divide by whatever coefficient you have on x. So the coefficient on x is 2. So your period is 360 divided by 2, or 180 degrees. That's your period.
It's always 360.
For a sine or a cosine, yep. Yep. Normal period is 1 time around the circle. All right, that's good. So cross off phase shift and vertical shift, and frequency got cut off already, but cross those off. You do not need to worry about those. But you do need to know how to find the amplitude and the period. Connor? 1C. Okay, 1C has a circle around it. Allie, was your hand up? No. Okay. What? 4A. 4A. Now, of all the logarithm problems in the world, this one is the most basic and fundamental. Sophia?
Is it 4 to the 3rd?
It absolutely is. Loop it. So 4 to the 3rd equals x. 4 to the 3rd equals x. Loop-de-loop. So the answer is 64. Yep. That's your answer. All right, who else has a question? Connor? 4B is a logarithm question, but it's a little bit more intense than the one we just did. So, Sophia, do you happen to remember, or have you done this with somebody?
Yeah, I'm from
So what do we do?
So I said logarithm, then okay. I said x plus 3 over x equals 5. I got 3/4 as my final answer, but
Okay,
this word.
and that may be the answer, I don't know, I have to work it out and see. But we need to understand what we're doing as we're doing it, right? So here we go. First thing, there are too many logarithms over here. We need to combine these two logarithms.
I said x plus 3 over x.
They combine by a division. Remember, if the logarithms are subtracted, the numbers are divided. So we can put these two logarithms, we can squeeze these two logarithms together into one by making that a division. Right? Remember that sort of vaguely? Now, notice that you have the logarithm of this equal to the logarithm of this. What just makes common sense then? That the two circle things should be equal to each other, shouldn't they? If their logarithms are equal, they should equal each other. So x plus 3 over x equals x. Oh, equals 5. That's a 5. I'm sorry. Copied it wrong. I thought, ooh, this looks strange. Yeah, there we go. That's a 5. Right? Yeah. So x plus 3 over x equals 5. So then we can times by x. Move this x over. So Sophia, you are exactly right. X equals 3/4. X does equal 3/4. Okay, who else found one? Okay, Diana, you need to wrap up here, sweetie, get to class. All right, so who else has one? Thomas?
5.
5. How much do I have in my account? Now, you'll have a formula sheet. And in fact, did you notice, I think the quest that you just took, the little formula sheet I gave you, had a couple of extra formulas on it?
Yes.
And those were the compound interest formulas. This is the formula. You don't have to memorize the formula, but you have to memorize this is the one you use when you are compounding interest quarterly or monthly or daily. This is your compound interest formula. So it says how much will I have in my account, what will be my ending amount if I deposit $1,600 at an interest rate of 3.1. Now remember, every time an interest rate, no matter what formula you're using, every time an interest rate goes into the formula, it has to go in as a decimal. Okay? So 0.031. It's compounded quarterly, so N is 4, and I'm doing it for 25 years, so 4 times 25 would be 100. Okay? Now, I can type that in on my calculator, and if I type it in exactly the way I wrote it, it should all work out beautifully. You should end up with $30,462.59. That's what you should end up with. The exam, I can't remember if I told you, the exam is not multiple choice, so you'll be writing, it's like a regular test, you'll be writing answers for everything.
Wait, is the exam gonna be exactly like this, or is this just practical?
These are just, it's gonna have, every problem on the exam is in this packet, but not every problem in the packet's on the exam, because I only have you for a regular class period. So if you know everything on the exam, everything on the review, you're winning. Okay, who else found something? Make sure you're getting that answer. Make sure you know how to type it in on your calculator. Because you lose points if you don't type it right. Nabi?
What lesson is that?
Huh?
You know what lesson that is?
This came out of chapter 3, I think of 3.6 maybe? I can't remember.
So for number 6,
What?
For number 6.
For number 6. How many radians is 500? Well, I think the other day we did a problem where we had to change from radians into degrees. This one is the other way. We have to change 500 degrees into some radians. Anybody remember how to do that? This is a little harder than going the other direction. Do you remember how to do this? Sean?
Pile away.
Yes! Look, he just walked in and he's got it already. He says pi over 180 equals something over 500. That's exactly right. Pi radians is 180 degrees, so x radians is 500 degrees. So we cross multiply, and we divide. And then we reduce. So zeros, remember those almost always have like an extra zero to get rid of. And we have 50 over 18, which is 25 over 9. Yep, so that would be your final answer after you've reduced. 4C is a calculator problem again. And it says we are solving this is a trigonometric equation we're solving. Okay. So what do you think will be the first thing we'll do? Well, I'm not telling you, because the first step is like kindergarten. You can do it. What's the first step? Look at the equation. What was the first step? Divide by 4. Sean's on fire. Divide by 4. Of course you're going to divide by 4. So now it says sine equals 3/4. So there's an angle out there somewhere. Diana, it's 9:15. You gotta go, sweetie. I don't know what you have, but that teacher's gonna be mad at me. All right, so somewhere out there's a angle that has a sine of 3/4. Now this is where you have to remember something important. Sine is affiliated or associated with y. You got to remember that. Cosine is with x, sine is with y. Why does that matter? Well, this is a positive number. So it's got to be somewhere where y is positive. So y is positive in quadrant 1. Everything's positive in quadrant 1. Where else is y positive? In quadrant 2. So you've got to figure out where to draw your triangles. Every time you have a trigonometric equation, you're going to draw triangles somewhere. You have to figure out which quadrant to draw them, and you know by paying attention to which function you have, sine, and whether this is a positive or a negative number. If it's a positive sine, then it's a positive y, and y is positive here. Okay, now, I could go ahead and label my picture opposite and hypotenuse, but that is not one of my special triangles, is it? It's not a root 3 and a 2, or something like that. So that's why I get to use my calculator. So I'm going to figure out what angle has a sine of 3/4. So second sine 3/4 is about 48.59. To find an angle on your calculator, you always second whatever the function is. In this case, second sine. That's how we find angles on our calculator. Second sine. Now, what are the actual answers to the problem? The actual answers to the problem will be this angle, which is 48.59, and this angle, which is not 48.59. How will I find that purple angle? 180 minus. So the purple angle is 180 minus 48.59, which is 131.41.
So it's what is both?
Both of them, yep, both of them. All right, who else? Let's hear from somebody new. You were all supposed to have looked this over.
4D.
4D. You heard me do that one? Okay. 4 and 8 are not random numbers. They have a special relationship. What is something that 4 and 8 have in common?
It's half.
Okay, well, there's definitely that, but that doesn't really help me in this
They
problem.
also have X's.
They're both powers of 2. So 4 can be written as 2 squared, and 8 can be written as 2 cubed.
You just simplify
If you have this is called an exponential equation. If you have an exponential equation and you cannot turn both of your numbers into the same number, so like 4 is 2 squared, 8 is 2 cubed, we turn them both into 2's. If you can't do that, then you're going to need logarithms to solve the equation. If it's a no calculator problem, then there has to be a way for you to make these the same. That's the key, make them the same. Because now I have 2 to the 4x minus 6. Remember, you multiply. Then you have 2 exponents. You multiply. And 2 to the 9x plus 3. So again, rely on your common sense. If 2 to this power is exactly the same as 2 to this power, what has to be the case? The powers have to be the same. So 4x minus 6 must equal 9x plus 3. So I got negative 9/5 if I did my arithmetic correctly. So if in the beginning, this number had been a 9 and this number had been a 27, could I do the same thing? Yes, only I would write 9 as 3 squared and 27 as 3 cubed, right? They have to be able to be broken down to the same number if we're doing it without a calculator. Okay? All right, someone new. Remember, we're all supposed to study. Connor, you're not new. I want to know how many of these you actually tried, Connor. You trying them? You're sitting there figuring out problems, which is fine. That's what we're doing today is practicing. But you need to put more time outside. Zach.
9B.
9B. 9B is an area problem. It says I get my calculator. And I know that this is 58, this is 16, this is 13. And I'm finding the area. Anybody remember how to do this?
You have to have that one equation, right? Triangle equation where you have 2 sides and 1 angle.
Okay.
I don't know the equation.
All right, so Zeke remembers that there is he calls an equation, a formula that will find the area of a triangle in this situation. This is like the best situation you can have because plug the numbers into your formula, and you're all done. Anybody remember?
This is a law of cosines.
Well, the law of cosines would find like this side, but it won't find the area. So law of sines and cosines do not find area. Law of sines and cosines find sides and angles.
Heroes formula?
Hero's formula is what I would use if I knew all three sides. I don't know all three sides, so I'm not gonna use Hero's formula. Oh, this is the easiest thing. 1/2 side times sine of included angle. 1/2 side, sine. That's how we find the area of the triangle. 1/2 side times sine of included angle. So your area is 88.20 basically. Now the other one in that section is a little bit different because why? What's different about problem A? There's no angle. So guys, if there's no angle, you're not doing it this way. Because you need an angle to do it this way. So we have another strategy when we don't have an angle. We use Hero's formula, and Hero's formula says, add up all the sides, find the perimeter in other words. So the perimeter would be 2636. Take half the perimeter, so that'd be 18. So where did the 18 come from? It's half the perimeter, it's called the semi-perimeter. And then how do I fill in all the rest of those blanks right there? I subtract each side from 18. So 18 minus 10, 18 minus 11, and 18 minus 15. So I remember when we actually did this, like the unit we were on, a bunch of you put 10, 11, and 15 under here. No, the sides don't go under here. What goes under here is 18 minus each side. And you just type them all in and square root them. So that area is 54.99. Type in exactly whatever it is. Make sure you're in degrees. Okay, well, that's why it didn't work. All right, so let's see. Ashlyn, what problem did you come up with when you were looking through all this?
I had trouble with all four, but I'll pass all this questions.
All right, so you've already done all four. All right, pick another one then, because you had to have trouble with something else. Which one? 12. 12 is kind of like this, it's got a triangle in it, but it's not area. So I am to find side C. Well, I just told you guys. How do you find sides and angles in a triangle? This is not area. We do law of sines or law of cosines, right? So we just gotta look at the problem and figure out, which one is going to be appropriate for this situation. So what do you think? All right, somebody said law of sines. Now remember, law of sines is a proportion. In order to use the law of sines, I have to be able to complete one of the fractions. So sine 47 over C. Sine E over 16, sine D over 23. Do I have any complete set?
No. But can't
It's
you,
not the law of sines. Can or what? Just say it. Don't mumble. What are you trying to say?
can't you find D though?
How?
Does everything add up to 180?
It does.
So you can just take a guess saying that it's like 43 to get you to 90. Sin E could be 90.
Okay, you don't get to just make up the angles, okay? You can't do that. And even if anything you said is remotely like doable, which it isn't, E can't be 90
Oh, yeah.
because that's the shortest side of the triangle.
Yeah.
Yeah, so, no, you don't make up angles. That's not how it works. You're not allowed to make up angles. The law of sines isn't gonna work. So we're gonna have to use the law of cosines. And what does the law of cosines look like?
Isn't it like the two angles and then cosine and
C squared equals 23 squared plus 16 squared minus 2 times 23 times 16 times cosine 47. That's the pattern of the law of cosines. These get a little bit tricky sometimes when you type it in, but not this one. This one we can just straight type in 23 squared plus 16 squared minus 2 times 23 times 16 times cosine 47 equals. Then we have to square root it. So after we type all this in and we hit equals, then you can do that if you want. Then we have to square root it. So you should get 16.82 when you type all that in. Okay, now, this, you don't have to in this problem, but once I know this is 16.82, could I then set up the law of sines? Yeah, if I needed to. I don't. I'm done. This is the answer to the question. But you have to have this set up if you're going to do the law of sines. If we don't know both of those numbers, we cannot do the law of sines. All right? All right, Navi?
Are these one of the equations you're gonna give us, or do we just
Law of
need to know them?
cosines you need to memorize.
Okay.
Okay, all right, so, Hadley, what about you? What did you find, Hadley?
Well, I don't have 10, but we already did a bunch of them.
Okay, well, find one we haven't done. We haven't done hardly any from the last couple pages.
I don't like that. You should be.
18. Find the fourth term of x plus 4y to the 8th. Okay, so we gotta stop and think about this for a second. If we were writing the whole, if we had to expand the whole thing, which we don't, but if we did, we would go to the 8th row of Pascal's triangle and get those numbers, right? Or instead of going, you know, clear down to the 8th row with Pascal's triangle, how else can we find those numbers? Do you remember? Oh, guys, we just did this. We can use the combination numbers. So the first term would be 8C8, 8C7, 8C6, 8C5. I'm just counting down. So the fourth coefficient is 8C5. That, you can get that number by building Pascal's triangle, but that takes a lot of time, and you remember, you only have a regular class period for this. That's it, that's what you have.
So it's AC5 when that they go to 1, 5, and
put that in our calculator?
Yes, you just put that in your calculator and figure out what it is. This is a calculator problem. So 8C5 is 56. So my term is 56. And then I'm gonna have an X, and I'm gonna have a 4Y. Now again, if I were writing out the whole thing, every term would have an X and a 4Y. The first X would be to the 8th. The second X would be to the 7th, and then the 6th, and then the 5th. So the power on that X is 5. I just counted down. I want the fourth number, 8765. And if that one's a 5, then this one has to be a 3. So I have a 56, X to the 5th, and a 64 Y cubed, 4 to the 3rd. So 56 times 64 is 3584. So the answer is 3,854 X to the 5th Y cubed. That's the fourth term. You did the whole thing out. That would be the fourth number in the list. Okay? Jake? What question do you have?
19.
What do you think, Jake?
That's 24 people.
Okay, Victory has thrown out for number 19. He has thrown out, what you say, 24? You say P or C? P, 24P, 4? And you have a different thought, or is that what we're going with?
Yeah, that's it.
Why is that it?
Because there's a
They're all
specific.
different.
Sizes are different, and they're different as permutations. So there's 24 people, I'm giving away 4 prizes. So I'll just type into my calculator, 24P4. And it's 255,024. That's all there is to it. Anytime you have a big group that you're picking from the group, it's either gonna be a P or a C, every time. You just have to decide which one of those it is. And then type it in on your calculator. So 20 is kind of the same thing, I'm picking boys and girls
But
now,
it's C.
but it's C.
So it's 6, C3, 7, C3, and then you multiply those answers.
Yep, because you're picking boys and girls. Yep, that's exactly right. I would type that in. I got 1,225. Is that right? Nope, it's not. I typed in 7 twice. There, let me start again. I typed in 7 twice and said 6.
You're just straight wrong.
And now I've typed in 6 twice. Oh my gosh.
Dude, I know what they're thinking. They got like,
Okay, I got 700. Did I do that right? Kyle? Kyle, it's got a circle around it. I don't, I mean, if you want me to put those on the exam, I will. I'm listening to Zeke. Zeke? Which one do you want to do?
25.
25. All right, we'll take a look at 25.
No matter what, they're not getting it. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. I feel so bad. I feel so bad. I feel so
All right,
bad.
let's, once you guys get started on whichever one Kyle said, I gotta get something real quick out the closet back there. I need to see.
Speak up, with your chest.
Mine wasn't valid, so.
And he was really dumb too recently.
It's so unfortunate.
Yeah, like he was really taking off.
They're not.
You never said it was your
All right, okay, which one am I doing? 25. 25. All right, this was actually a test question, one like it, one very similar to it. We have an octagon, the picture's already drawn. And our job is to find the area of the octagon, and we know the radius is 10. Okay?
Well, first, the other side is 10 too.
Okay, I could draw in all of these,
And then I
and
need
every single one of those would be 10, right?
60 divided by 8 to find the angle.
This angle right here,
It's 40.
look, there's 8 of those guys, right? 8 of those angles. 360 divided by 8 is 45.
And then you gotta do the formula.
And then we have our triangle formula, which is 1/2 side times sine of included angle. Right? So I can type that in on my calculator, but be careful, that isn't the answer. Because, why?
Gotta divide it.
No, no.
Multiply
This
by-
is the area of the triangle.
And then you multiply by
How many of those triangles are there?
8.
8. So I'm gonna multiply by 8, and the area, the final answer is 282.84. That's your final answer. So we type this in, that's the area of the triangle. Then we have to multiply that by 8 because there are 8 triangles that make up the figure. Right?
He's only gonna get one of these, right?
Why would I put more than one on? Thomas? 21. A 5-card hand is dealt from a standard deck. Find the probability that you will get at least 3 aces. Now, before we start, let's make sure we understand, what does at least 3 aces mean? How many aces can I get? I can get 3, or I can get 4. Can I get any more than that? No, because that's all there are. But remember, it's a 5-card hand.
So would it be?
So if 3 of them are aces, the other 2 are not, right? So Brendan says 4C3, and that's right.
Times 48
And 48C2. That is,
over 52C5.
yes, that would be the probability, this right here is the probability of getting exactly 3 aces. Right? Now, what's the probability of getting exactly 4 aces? Probability of 4 aces would be 4C4, 48C1. Because don't forget, it's a 5-card hand, and if we're doing a 5-card hand, we have to have another card if 4 of them are aces. And that's still over 52C5. So your calculator will do this, and your calculator will do this. What do we need to do to those 2 answers? Add them, because it's 3, 4, 4. So those get added together. And your calculator will do it all in one sheet. You can type all that in at one time, if you want to. That will work. See if I can keep track of this stuff. I got, and I'm having issues today, so I'm not gonna guarantee it, but I got 00175 as my answer.
Yeah, you're right.
Go to find more answer. Okay. Who else found something? Connor,
You go over 22.
what have you done with 22?
I did all this, but I forgot where.
Okay, so he has a tree diagram on his paper. That seems like a good strategy for this problem. When I read it, it just seems like that would be a good way to do it. Now, he can't label his tree diagram. Can somebody, yeah, obviously, can hear what I have said. Can somebody else tell him how he should label his tree diagram? Not numbers, but words to get us started. Navi?
So, going off the problem, the bottom one should be in uniform or out of uniform.
Okay, so this one's gonna be in uniform or not in uniform, because that is the question that's being asked, and we always put the question that's being asked at the bottom of the tree. So then what's the other thing that's going on?
If he's late or not.
Late or not? So this is gonna be late and not late. And now we can actually start putting some numbers in. If he's late, the probability he's in uniform is 0.38, which means this one's 0.62. If he's not late, his probability of being in uniform is 0.68, so this one's 0.32. 24% are late, so 76 are not, unless of course it's this class, and then those numbers are reversed. Find the probability that a randomly selected student will be in uniform. So we want this one and this one. Those are the uniform, in uniform things.
They have to equal, was it 1?
No, each branch equals
Yeah.
1, those two equal 1. So 0.24 times 0.38, that is I am late and I'm in uniform, or I can be not late and in uniform. So I need this branch right here, and I need this branch right here, one or the other, so I'm going to add them up, multiply and add. So 0.24 times 0.38 plus 0.76 times 0.68 is 0.608. So about a 60.8%, if you want to answer it that way, yeah, that would be fine.
Why wouldn't it be only one side, like the left side? Because it said if they're late, find the probability that they will be in uniform.
It says 24% of the students are late. Find the probability that a randomly selected student will be in uniform. All right, another one. Who else found one? Piper, what did you come up with? Ms. Piper?
It could be
we just went over it, but I know I got it wrong on the test.
Okay.
So,
And this is one of the harder ones because you have to separate it because the 0.2 is not part of the repeating. So this is separate. This has to be done after we do the rest. Our formula will do this. And our formula is the infinite geometric formula, which is this one. So what's our first term? What's the first term of the actual repeated part? 0.07.
Over 90.
And what is the ratio? 0.1. Because there's only one repeating decimal place, right? You wanna take this in? Okay. Okay, there's only one repeating decimal place, so it's 0.1. So I like to go ahead and subtract that denominator. So 1 minus 0.1 is just 0.9. Now I gotta move those decimal places. So I'm gonna move it 2 places to get rid of that top decimal. But I gotta move this one 2 also, so I have 7/90. Now, 7/90 isn't the answer, because remember what we did? We pulled that off. So we gotta do 2/10, that's 2/10, plus 7/90. So it looks like our common denominator is 90. So I have 18 plus 7, 25/90, which actually reduces to 5/18. And then, since you have a calculator, you can check that. 5 divided by 18, oh my gosh, there it is. Right? So, Allie, you can check your answer, and then if you don't get it right, you can go back and try to figure out what you did wrong. What's the limit of 27A? 3/5. What's the limit of B?
0.
No, it's
It's not.
Zero. It's 0 because 4/5 is less than 1. Number 24. Did we already do 24? The other day, I can't remember. So Eli caught 2 baseballs on the first day of the season, 5 on the second day. So 2, 5, 8, 11. Okay, so these are the number of baseballs that he has
You're adding
caught. So, Brendan has observed that this is an arithmetic sequence, right? Now the question says, how many will he have caught altogether if he continues this pattern for 100 days? Now, do I want to know the 100th number in the list? Or do I want to add all these up, all of them up to that point? Do I want to add all of them up? Read the question, look at the grammar.
Oh, added.
How many will he have caught all together? Doesn't that mean add them up?
Yeah.
Your arithmetic sum formula is this one. You're adding up 100 terms. So n is 100. It says he does this for 100 days. What's this?
The
Two. That's 2. Oh no. What's this?
We don't know.
We don't know it. That is the 100th term, isn't it? Isn't that this actual number right here? So now what do I do? If I don't have a number that I need, what am I gonna have to do? I'm gonna have to go back and use my other arithmetic formula, which is this one. And the 100th term of that will be the first term. What did you tell me the difference was, the common difference? 3 times 99. So that is
It's 299.
299. That is not the answer. That's what goes right here, right? I got 15,050 is the total number of baseballs that he will have caught in the first 100 days. So when you read the question, you have to really look carefully. Am I looking for just the 299? What would the question say if the answer were going to be 299? How many baseballs will he catch on the 100th day? Right? This is how many he catches on the 100th day. That isn't what it says. It says how many will he have caught altogether. Right? Okay. Here's, which one?
28.
Yep, 28's last one. I gotta get the video uploading. 28. Now, for this problem, you have to be able to find everything, because the test question might not be just find the vertical asymptote. It might be find the horizontal. Might be x-intercepts, y-intercepts, holes. Okay? So you need to be able to find all of those things because you don't know exactly what the question is going to ask. But you won't have to graph it. You're not going to have to graph it, but you'll have to be able to list any combination of these. So what's the first thing we're going to do? What's the first thing we're going to do in this problem?
Even it out. Make it so that it's all even. Boil it.
Factor it. Yeah, first thing we're going to do is factor it. That is step 1. Factor the problem. The reason that you factor the problem is that what happens sometimes, you can cancel. And if you can cancel, you will have a hole. Now, since nothing cancels, we don't have a hole. So if the question had been, where is the hole, you would say there isn't one, right? Now, tell me what you don't have to sketch. I'm just gonna do a quick sketch and you do not have to sketch. Tell me something there that I know from looking at this problem. What can you fill in?
The horizontal.
What's the horizontal asymptote? The horizontal asymptote is y equals 1. The horizontal asymptote is y equals 1 because that's the limit. The limit is the horizontal asymptote. X squared over x squared, so that's 1. What about the vertical asymptotes? There's 2 of them. The vertical asymptotes are at -3 and +3. Where do vertical asymptotes come from? The denominator, whatever makes the problem undefined. If you put in 3 down here, don't you get a 0 in the bottom? You're allowed to have a 0 in the bottom? No. All right, I got my horizontal asymptote. It was not the y-intercept. Here's the horizontal asymptote. Okay. Now what about my intercepts? Where are my intercepts? So the x-intercepts, or the zeros, are at 1 and negative 1. That's exactly right.
And then
Where do x-intercepts come from? The numerator. That's exactly right. They come from the
and then
numerator.
the y is 0, 3, 0.
No.
No? It's not that.
If I put 0 into my problem, I get 1/9. And that is your y-intercept. 0, 1, 9. So if you sketched it, which you don't have to do, you would get a picture that looked like that. That would be what it looks like. All right, we've got one more review sheet. You need to come with some of those done.